Hello everyone, welcome back to Calculus 3. And today we are going to study section 2.3, dot product, another kind of vector operation. And first let's take a quick look how the dot product works out. If we are having a vector, remember vector it is an n tuple. So if you have a two-dimensional vector, it's just an ordered pair. If you are having a three-dimensional vector, that's an ordered triple. But anyway, I'm doing the general case. Okay, for any kind of vectors, vector u and v, and then u dot v. It is a multiplication, but the multiplication it is carried out like in this fashion. You multiply the corresponding components together, and then you add all the products. And the one thing it's worth to note, okay, like the not like the operations we covered before. I mean the scalar multiplication, vector addition, they are generating new vectors. The dot product, indeed, it is generating a scalar quantity. The dot product, it is a scalar quantity. Seemingly, it may still look pretty long, but anyway, I hope you are seeing we are adding some numbers together. So overall, it is still a number. A scalar quantity, it is a single real number, and we want to emphasize really it's not a vector. So it's a scalar quantity. Dot product, it is scalar quantity. There are several reasons why we want to make this arrangement for the dot product. Well, one simple thing, when you have two vectors, like two-dimensional vectors, three-dimensional vectors, literally they can be considered line segments. So two vectors are two lines. So you need, when two vectors are perpendicular, or more precisely, we say orthogonal. It can be determined, it can be detected by checking with the dot product. If u dot v equals 0, that means u and v are perpendicular, or u and v are orthogonal. And also in a more generalized case, remember factors, we can shift vectors. We can always arrange any vector starting from the origin. So vector u and v, it can be arranged in this fashion. And clearly one interesting thing, as marked on this figure here, there's an angle between those two vectors. So how do we find out those two angles, that particular angle? The angle can be found using the dot product. Specifically, the angle will have to satisfy this equation. Cosine theta is, u dot v divided by the norm of u times norm of v. Look at the fraction. Looks like we have u and v similarly cancel, but anyway, they don't. The top numerator, it is dot product, right? So it is a scalar quantity. The bottom, this is the magnitude of u and the magnitude of v. So these are scalars, and the multiplication that is still scalar. So overall, we are having a number. And the cosine theta, it is the dot product over the product of the magnitudes. How about let's take a look at one example on the textbook. I took out the checkpoint 2.25 here. Okay, we want to find out the angle between vector A and vector B. So accordingly, here's what I did. Because I'm checking with the formula, I needed to calculate the dot product. So I did that. And also I did calculate the norm of A. Hopefully, I think I'm correct. And also I calculate norm of B. And I think that looks fine too. So basically, I should write cosine of the angle is the dot product over the product of the norms. Okay, but anyway, I hope you can tell the angle. If cosine theta equals such a number, then theta is the inverse cosine, arc cosine. So theta, in this example, I just wrote theta is cosine inverse of this dot product. So accordingly, this part, dot product divided by the product of norms, turns to be this number. And again, I want you to know, well, in my class, it is always required you provide exact answers and exact answers only. So indeed, this is perfect answer. And also, just in case, if you wonder if what this angle would be, I say it is in the radian measurement. In the radian measurement, okay, you can use your calculator to find out this angle, and also make sure you do. If you need to see the angle, check the angle measurement. It is set correctly to radian. In general, this is the radian measurement of the angle. How about one more example? Dot product. We mentioned that there is a special case when the angle it is 90 degree. It is two vectors are perpendicular, right? Orthogonal. So we want to say, by the way, it is consistent to the special case, right? When the angle it is 90 degree or pi over 2, cosine pi over 2, which is 0. Dot product, and neither cosine theta is 0. So the dot product must be 0, okay? So let's take a look how we can decide this problem. For which value of x is the vector p, like such, 2, 8, and negative 1, orthogonal to vector q. Q has an x there, x, negative 1, and 2. So the solution, I suppose, it is very simple, because we know when p is orthogonal to q, then p dot q must be 0. So this is a calculation I did. Hopefully, let me double check. I believe it should be all right. 2 times x minus 8, then minus 2 equals 0. So accordingly, x must be 5. X must be 5. Hey, this is the topic of section 2.3, dot product. Thank you for watching.